Hi there, Xi 6B.1. We're looking at the equation of a straight line. Some work we've done really at GCSE, but perhaps dress it up in a slightly different way as well. So, but a lot of this should be overlap with old stuff, really. So just on that basis, here's some starter exercises. You'll notice a variety of questions looking at equations of straight lines, and one of them at least, or two of them actually, looking at are curves. Three of them, having said that. So these are a mixture of different types of curves. Now this is, because of the x squared there, this is what we'd call a quadratic. As soon as you get a quadratic, an x squared, you know it's quadratic. Obviously by definition then this one is a cubic. And this last one is actually a circle. So it goes to show something. You get different types of equations for different types of things. I think even circles you were meant to have seen at GCSE. So anyway, what are we doing? We're looking here at, find the y coordinate on the curve. So basically you're going to sub these two values into this equation to get y equals this or y equals that. Likewise, this other one, it's a bit backward, this one. You're told that y equals 7, which effectively means you've got to solve an equation to work out what x is at these 2 points. For 3, I want you to sub 1 in to see whether or not 1,13 lies on this line. Now, if when you sub 1 in to the equation, you get a value of y equal to 13, you go, yes, therefore it is on the line. But if you sub 1 in and you don't get 13, then you say, no, it's not equal, and therefore it's not on the line. So that's all you're doing. And then what's this last one? Determine whether, this is exactly the same idea. Now these, because of the way they're written, it's probably easier to sub both of them in. Put -1 in, put a half in, and see if you get 1. If you do, it's on the line. If you don't, it's not on the line. Anyway, so pause the video, and then you can do all of those, and then you hopefully will get the right answers. Okay, hopefully you've done that, and you've now got the answers. And so here are my answers. So I'll just go through them. You can look at them at your leisure and make sure you've got them right. If you haven't got any of them right, go back and check. Anyway, so we're going to look at what we're going to call the gradient intercept form. As you can see, I've written that as y equals mx plus c. You can see why it's called the gradient intercept form, because we already know from GCSE that the m is the gradient and the c is what we call the y-intercept. And that, as it says, is where the straight line meets the y-axis. So, for instance, if I had y equals 2x minus 1, we know immediately the gradient is 2, m equals 2. Notice I'm not writing the gradient is 2x. That would be wrong. It's effectively the m, the gradient, is how many x you have. And the y-intercept, by definition, is the number at the end. So hopefully you're going to say it's -1. And it is. So what does that look like as a graph? Well, it basically crosses. That's the first thing I think about this. I think it crosses the y-axis at -1. So notice at -1 there, I've put my cross. Now the fact that it says the gradient is 2, what I think of that is it goes 1 across. It's always 1 across, by the way. If the gradient is 10, they go 1 across as well. But when I say 1 across, I go 2 up, and there's my next point. I go 1 across, 2 up, and there's my next point. 1 across, 2 up, and there's my next point. And you just keep on doing that. Now you can go the other way. So if I go 1 left, I go 2 down. I go 1 left, I go 2 down. And you can see these points all form perfect straight lines. So it's no surprise that we draw a straight line through them. It just works really well. That said, you get this alternative way of writing it, and this would be called a general form of the equation. And sometimes the c is over on that side, if it makes it look a little bit prettier. And sometimes it's on the left-hand side. Basically, we like positive numbers. So if it was 2x plus 3y minus 10 equals 0, we'd probably put the minus 10 on the other side and say, well, however many x plus how many y equals 10. And so we tend to like these instead. So it doesn't take much to see that all I need to do is move that over there on this equation, y equals minus 2x plus 1. The minus 2x becomes a plus. So I'd get 2x plus y equals 1. Oh well, let's move the 1 over as well. 2x plus y minus 1 equals 0. Now, this way, I actually don't like this one because it's got a negative. So, I'd probably prefer that. But they said, show that it can be written like that. So, we have. So, boom, boom. Thank you very much. Oh, I've got the answer here, so I better make sure I get it. Find the gradient and the xy intercept of the line with that. Right, so on a question like this, what you're looking to do is, you'll notice it is in the wrong form. It doesn't look like what we'd normally be able to use. If it looks like y equals mx plus c, then I know the gradient and I know the y-intercept. But here it doesn't. So if it was me, I'd try and get the y on its own. You'll notice at the moment I've got a negative 3y here. So I'm going to move that over. I just don't like having negatives, as I said. So I'm going to move that over. It'll leave 4x plus 7 on the left equal to the 3y. Notice the minus becoming plus. And then all I'm going to do, I'm going to divide by the 3. So when I divide by 3, I'll get 4. Notice I do both bits divided by 3. So 4/3 of x plus 7/3. And technically it should say equals y here, but I'm going to put it at the front. It's just a bit neater. So once we're in this form, you can see this is now looking like y equals mx plus c. So my m must be 4/3. That's why it says here your gradient is 4/3. My y-intercept, I don't know why I wrote that. That should have been a c. My y-intercept is 7/3. And the y-intercept is 7/3. Yes. The one that's not obvious is this, what it's called the x-intercept. Because so far, I could actually draw what I've done so far. I know it's crossing at 7/3, which is 2.3ish. So there you go. And it's only a sketch, it doesn't matter too much, so I'm going to draw it something like that. This is y equals 4/3 of x plus 7/3, or this is 4x minus 3y plus 7 equals 0. Now, what I want to know is where it crosses here. This is called the x-intercept. Now, the way we do that, to get the x-intercept, we simply use the fact that this could quite easily be called the 0 line. And if it's the 0 line, it basically means the y value is 0 there. This is y equals 0. Now, I've got an equation with where I can say, well, y is 0. So, which one should I use? I could take my pick. I actually think I prefer this one. This one looks much nicer. No fractions here. So I'm going to write 4x plus 7 equals 3 times 0. Obviously, 3 times 0 is 0. So there you go. Move the 7 over. 4x equals minus 7. And therefore x equals minus 7 over 4. Which is what we said. So we had the answers. I'm not sure if all the of these can know that was the only one that gave me the answers. So anyway, a couple of questions as an exercise. Find the equation of the line with gradient 2, which passes through the point 0 minus 1. Now this is perfect actually for an equation of the form y equals mx plus c. Because I'm told the gradient, tick, and I'm told this basically is the y-intercept. Look, it says 0 across, so it's on this line, minus 1. Down 1. That's the y-intercept. So I know the c as well. So the first one is nice and easy. It's y equals, what was the gradient? The gradient was 2. So 2x. What was the y-intercept again? It was minus 1. That's what I said there, minus 1. That's the equation. There you go. Easy peasy. Question 2. What does question 2 say? Find the axis intercept of the line 2x minus 3y. So again, we're looking at one of these things where they're given an equation. Now, this is actually quite nice and easy. It's not hard. Now, let's just think about it for a bit. We have the y-axis. Now, on the y-axis, we can say for certain anywhere on this line x equals 0. And as I've already said to you, on the x-axis, we can say y equals 0. I've even called this the 0 line. It's obviously only the y equal to 0 line, but so we can use that fact. So I can just write when x equals 0, and I can sub 0 in. It will tell me where it crosses the y-axis. So I'll get 2 times 0 minus 3y equals 12. And again, you can almost ignore this bit because it's nothing, and therefore minus 3y equals 12. Y equals 12 shared by the minus 3, which is minus 4. So actually it crosses down here somewhere at minus 4. And the other one we've got is when when y equals 0. So when y equals 0, again look at my equation, this is now 0, so it's 2x minus 3 times 0 equals 12. And again the same rule applies, anything times by 0 is 0. So I can get rid of it. 2x is 12, well, x is 6. So it crosses over here at 6. So in actual fact, my line looks something like that. It's a straight line through. -4 on there, and 6 on there. Have I drawn a picture? Yes, I have. There it is. So that's what we're doing in class. You'll get plenty of practice in class. Hopefully it makes sense. It should be fairly straightforward because it's quite like GCSE. And hopefully that's okay.